A parallel plate capacitor is the most fundamental configuration for sensor and actuator. It consists of two conducting plates with their broadside parallel to each other. In broader definition, these two plates are not required to be exactly parallel, but they are required to be planar. The value of capacitance C between two plates is defined as Q over V, where Q is the amount of torque charge and V is the electrostatic potential. The capacitor can be used as an actuator to generate force or displacement. The electrostatic force between the capacitor plate generated by applying a voltage, where E is the permittivity in vacuum, D is the gap, A is the area, K is the spring constant of the cantilever, and Z is the amplitude of deflection due to voltage.
Assalamualaikum and hi, I am Muhammad Yusri bin Zainuddin from RK86, and for my part I will be presenting about MEMS fabrication using MEMS Pro software. In layout section, first image shows the overlapping of 4 layouts. Layout can be referred to as mask for later use in etching process. Each layout has different shapes and location. In the layout dimension, we have assigned the location with X and Y center as 0 is the origin or reference point. For the shape, we have assigned the width and height parameter. If use a circle, then radius is assigned. We assign material nichrome, silicon carbide, polysilicon, silicon dioxide, and silicon. The material properties include coefficients, elastic moduli, major and minor portion ratio, and mass density. Thank you.
Assalamualaikum. My name is Nurul Safira binti Muhammad, metric number 181031736. I will be present the MEMS fabrication simulation. Based on our design, they have 13 steps for the process definition. For the step 1, this is silicon substrate material. Next, we deposit silicon dioxide material on the silicon substrate. And then we deposit polysilicon material. Then we achieve half of polysilicon material. Next, we deposit silicon dioxide material. Next, we achieve half of silicon dioxide material, and then we deposit silicon dioxide material. Then we achieve half of silicon dioxide material. Next, we deposit poly-SiC material. Then we achieve poly-SiC material to achieve shape cantilever design. Next, we deposit an ICR material. Then we achieve an ICR material to achieve shape cantilever design. And lastly, we achieve sacrificial of polysilicon. Based on picture above, this is the final 3D model and cross-section of our cantilever design.
The next slide is MEMS finite element analysis using ANSYS R2 software. In our group, each team member are assigned to produce results based on material properties and cantilever dimension. In the analysis system, we have chosen static structural analysis to determine the total deformation, equivalent stress and strain by having force as the input analysis. In the geometry, our 3D model has the dimension of 0.06 times 0.03 times 0.02 millimeter. In the engineering data and model, we have assigned 4 materials with density physical properties and linear isotropic elasticity. In the mesh and input boundary condition, we assign a force of 3 millinewton on the top surface and fixed support at the bottom.
For the finite element, our group have been used different parameters for ANSYS simulation such as width, material, length and thickness. This is the graph result of different parameters. For the width graph, it's shown when the value of the width of poly-SiC material is increased, the total deformation becomes decreased. But at the width 36 mm, the total deformation becomes increased. For the material graph, it uses different materials such as NiCr, copper, nickel, and aluminium. Based on the graph, for the material copper, the total deformation is larger than the other material. For the length graph, it's shown the line graph represent different value of length. For the length 1, 2, 3, 4, and 5, it represent value length of 60, 70, 80, 90, and 100 micrometer. The total deformation become decreased when the length is increased. And then for the thickness graph, it's shown when the value of thickness of poly-SiC material is increased, the total deformation become decreased.
Hello everyone, my name is Amir Rahman bin Ismail, Now I would like to present about the MEMS capacitive actuator for campus sustainability. First of all, after discussion among team members, the campus sustainability idea is a smart bus shuttle. The idea makes them more reliable and convenient by introducing the digital signboard and push button to count the number of waiting passengers and the number of the passenger on board of the bus shuttle. For example, if 3 passengers at the bus stop want to use the bus shuttle service, they will press the push button 3 times, then the bus shuttle station will receive the total number of passengers. After the bus has arrived, the 3 passengers will enter the bus. The pressure sensor located at the bus entrance will count the number of passengers on board the bus shuttle. It will display at the digital signboard at every bus stop so that the other waiting passenger at different bus stop will acknowledge if the bus is full or not because of social distances due to COVID-19. Next, there are a few United Nations Sustainable Development Goals that we can relate to our project. The first one, to ensure access to affordable, reliable, sustainable, and modern energy for all. The second one is make cities and human settlements inclusive, safe, resilient, and sustainable. The next one is ensure sustainability, consumption, and production pattern. Finally, to promote peaceful and inclusive societies for sustainable development, provide access to justice for all, and build effective, accountable, and inclusive institutions at all. Okay, so saving fuel energy consumption is a demand in sustainable development goals. It can reduce the usage amount of non-renewable energy sources and reduce the air pollution caused by the bus. A smart bus shuttle is proposed by utilizing the MEMS capacitive pressure actuator for the buttons and bus entrance. This smart bus shuttle solution will create higher efficiency in terms of university bus shuttle service, time for students or people to use the bus, and reduce the air pollution around the campus environment. Thank you.